Hello, hello. Wow, good big house. Great. Well, welcome everyone to the first colloquium of the fall semester. My name is Al Winchick, and I'm the research manager for the Natural Resources and Environmental Studies Institute. I will turn off my phone. There we go. Yes, here at UMBC. And before I introduce Michelle Connolly from PICS, who will introduce today's guest speaker, I have a couple of announcements. So, next week, September 22nd, our presenter at the colloquium series will be Dr. Ning Chen from the Canadian Light Source. And that's a co-presentation with the physics department. And he'll be talking about a molecular scale approach, X-ray absorption spectroscopy in environmental study. And then the following week, on September 29th, we will have Dr. Chelsea Armstrong from the National Museum of Natural History, so part of the Smithsonian Institute. And she'll be on hand presenting Historical Ecology in the Pacific Northwest, Indigenous Management of Forest Garden Landscapes. So I will turn it over to Michelle.
Thank you, Al. My name is Michelle, and I'm the campus coordinator and program manager for the Pacific Institute for Climate Solutions here at UMBC. PICS is sponsoring today's guest for the NRESI Colloquium Series, Dr. Dominick Dellasala, because of his important work at the nexus of science and policy at the state and federal levels in the U.S. Today, he brings us decades of experience as a researcher of forests, fire, conservation, and climate change mitigation and adaptation strategies. Dominick has written countless papers and several books on these subjects and is the president and chief scientist of the GEOS Institute based in Ashland, Oregon. Dominick is originally from Brooklyn, New York, and used to be a member of an actual street gang. Please join me in welcoming Dr. Dominick Dellasala.
And by the way, the street gang experience pays off for me because I'm testifying in the U.S. Congress in 2 weeks. It's good to have a thick skin. All right. Afternoon, everybody. It's so good for me to be here. Yesterday I was out at the Ancient Forest Park and had a wonderful field trip, did the evening program presentation, and then I got an amazing experience meeting the students and faculty at this wonderful university and being hosted by PICS. Thank you so much for taking the time out of your schedule, for allowing me to be here and meet many of you and interact with all of your incredible brains and the research that you're doing and how meaningful that is to the work not only here at the university but society writ large. So, how many folks have heard of the Anthropocene debate that is raging right now? Okay, so the Anthropocene is really the topic of today's discussion, and I'll lay out some of the debate that's been happening around that in the literature, and also what it means from a pragmatic standpoint in terms of what's really happening on the planet. And I'll define what I think it means as we go along with the slides and why we need wild places in order to get us through and the rest of the critters on this planet that we share this shrinking globe with in this great acceleration that we're going through right now in terms of human population growth and the degradation of the planet's life-giving natural resources. Here's a forthcoming encyclopedia that I'm heading up. I'm co-chief editor with some colleagues, and we have a team of 6 scientists from around the world piecing together this encyclopedia of the Anthropocene. It has several volumes in it covering things like chemical contaminants, nuclear war, biodiversity, climate change, ethics. We covered a wide range of topics in here. I think there are over 250 articles that are assembled in chapters published by Elsevier on Science Direct. You have to have a subscription to access it, as this is unfortunately not open access. So hopefully your library will purchase it, and you'll be able to get a copy of it and use it in your curricula. But it really was trying to put out there, what does this Anthropocene mean in terms of its impact on the planet? There may be a debate raging as to whether or not we're in a different era from a geological standpoint. And we could talk about that debate, and we can also put it aside and actually look at what's going on across the globe in terms of our footprint. And I chose this cover for the encyclopedia. You can kind of see the handprint here, and you notice that it has the contours of Africa in there, the origin of human evolution, the cradle of human evolution in Africa, where we had the first human beings that managed to evolve in different clusters on the continent. Was that the beginning of the Anthropocene, when humanity emerged out of the African savanna? Or was it some other point? And so when geologists look at the Earth's strata, they group it into different eras, periods, and epochs, as you can see there on the slide, depending on how many years ago that particular chunk of the crust had its origin. And so we have been in the Holocene now for almost 12,000 years. And what's unusual about this is geologists don't really categorize the era that they're living in. It's usually looking back in time instead of looking in the present. So I think that's where a lot of the controversy is right now. Can you categorize an era or an epoch that we're actually living in instead of looking back in the Earth's geological history? And as you can see, we've got a long history that goes back, over 4 billion years into how the planet was evolving and going through these different eras and epochs. So now, looking at where we are now, have we emerged out of the Holocene and into the Anthropocene? That's what the debate is right now. And during the Holocene, we have existed in this Holocene sweet spot for climate. You can see that the climate average temperatures over long periods were in a very tight confidence interval. And during that time, we had the advent of agriculture, because the climate was really suitable, and we had some warming periods and some cooling periods, the Little Ice Age, but generally it was within the human climate envelope. And you can see what happens towards the 21st century. We shoot up. And that overshoot of that climate sweet spot is what we're all concerned about right now, and what that means for the climate of the Anthropocene and further human evolution is where the controversy now lies. So when do you pick the starting point if you agree that we are in a different period? And geologists like to use what's called a golden spike. We need to drive a golden spike into the strata and say, okay, we're in this particular period, we're going to call it whatever. And so you can look at the bar graph down below here. We've got the emergence of human evolution with the first fossil evidence 3 to 4 million years ago. It used to be Lucy, now it's already the oldest human fossils on the African plain. That might be where you place the first spike. Then we had, about 2 million years ago, tool use. Okay, we drive another spike in there. That was pretty significant. Not that many animals have figured out how to use tools, and that comes with the manipulation of the environment, the development of the neocortex. Humanity was evolving, mostly in relation to its opposable thumb and its use of tools and how that affected the brain development. Now you leapfrog into, wow, we got really good at tool use and we caused these megafauna extinctions in different continents across the globe, correlated with human migrations and human presence over that time signature. Then we make another jump over into agriculture. About 11,000 years ago in the Middle East, we had the advent of agriculture. Large landscapes were being terraformed. River systems were being diverted for agricultural needs. Forests were being chopped down as agriculture was expanding. So another spike gets driven there. Then the Industrial Revolution. So you might want to put more than one spike in that period because we started using fossil fuels at a noticeable level, started transforming the climate, mainly because the carbon dioxide that was placed into the atmosphere at that time is still there now. There's a hang time, or a hangover effect, if you will, of CO2, and a lot of that started during the Industrial Revolution, which is starting to change our climate. And then you skip ahead to World War II. We had the advent of plastics in the environment for the first time, and how that affected not only the ecology of our environment, but the use of fossil fuels, the atomic age, and then we were off to the races. Notice what happens to human population growth as we get to about 1920, 1960, then we shoot up. And we're in the Great Acceleration. Look at what's happened to the planet's systems. Big increase in methane production, big increase in carbon dioxide emissions, tropical deforestation's going up, ocean acidification's going up, all around the same time period, right after World War II. That's when we can start placing a multitude of spikes into the new era. So some people say it is during post-World War II, some people say it was the advent of atomic energy, other people want to go further back. I don't care where you put the spike. The most important part of this is how quickly it's accelerating in the last 6 or 7 decades. So I think that's where we can arguably say that, yes, on a planetary scale, based on how we've altered the planet's life support systems, we're in a new era. And during this debate, there have been a number of articles back and forth, some of them in the conservation biology literature that I've been involved in, others in different periodicals and books and discussion debate forums. And the argument goes something like this. Development is good because it raises everyone's standard of living, and that's good. Nobody wants to be in poverty. Pristine does not exist. Nowhere on the planet do we have pristine ecosystems. Everything's been influenced by humanity in one way or the other. You go up to the ice caps and you can detect all kinds of chemicals that have been spread by oceanic currents. Nature's resilient. Polar bears are going to have to learn how to swim. Protected areas are old school. Natural systems should be managed to benefit humanity, especially the poor. Native or non-native species, what the heck, just figure out which ones we want. It doesn't matter, everything's getting mixed up anyhow. Nature will exist in pockets of human space, and overpopulation is not a problem. The argument continues. The Anthropocene can actually raise biodiversity. And I'm very happy to report the apocalypse has not happened. We haven't seen as many extinctions as we thought were going to occur earlier on. So this is, from different points of view that were reflected in some of the citations you saw in those 2 slides. Now I'm going to take that argument apart. Could the Anthropocene raise biodiversity? Every major biome on the planet is in decline. Coral reefs, the well springs of the marine ecosystem. We cannot have fish or food that we eat on our table without coral reefs, without the nursery grounds of mangroves. And you can see how much degradation has happened, not only to the coral reefs, but to the mangrove ecosystem on a global scale. So the ocean is the only place we still get wild protein from, and it's in major disruption. Forests, which is where I work. Half of the world's forests are gone. Deforestation over the last decade was about 13 million hectares per year because I used to play ice hockey until I gave it up because Canadians were a lot better than me. About 7,200 ice hockey arenas per hour are being deforested globally, or about 120 ice hockey rinks per minute. That's what 13 million hectares per year means. in terms of forest losses on a global scale. Most of those losses are in the tropics, but not all of them. As you know, in Canada, you've got your host of forest issues as well, and so do I in America. Okay, so the extinction apocalypse has been greatly exaggerated. And so let's look at some more figures. And this is from the United Nations. World's ecosystems are at risk of rapid degradation and collapse. Unless swift and radical and creative action is taken, we're going to have massive losses continuing. According to the IUCN, you can see the number of at-risk species. Since 2003, there has been an increase in that number, not a decrease. 1 of every 3 amphibians are at risk of extinction. Half of the world's turtles and tortoises, 1 in every 4 mammals, 1 in every 5 sharks and rays, on and on and on. Threatened species are increasing across all taxa. Okay, so we haven't hit the extinction apocalypse, but we're getting pretty darn close to it. And it's not within the normal bound. And so we know that this is what is the kind of average extinction background rate of about every 1,000 mammal species, less than 1 went extinct during millennium. That's kind of the background. Here's where we are now, 1,000 times higher than the background. Here's where we're headed with climate change and continued pressure on those ecosystems and the biomes that you saw from the previous slide. Yeah, we're heading towards that apocalypse. We're not there yet, but we're creeping along, actually accelerating along. Okay, overpopulation. It's not a problem. This paper came out, Anthony Bernowski in Nature a few years ago, showing a series of graphs here with the amount of the Earth's surface that has been transformed over time in relation to human populations. So back in the 1700s, you can see we had a sliver effect on the global system, and we are right about here at about 7.5 billion humans now on the planet, and we're heading in this direction. So at some point, we're going to cross a planetary threshold. And once we cross that threshold, it's a downward spiral. So population is a problem, and it's going to continue to be a problem because there's just so many Earths that we have here to draw down, right? We're really transforming or terraforming the planet at an unprecedented scale. Could it raise human well-being? It's a great idea, and we all want to eradicate poverty and increase everyone's standard of living so that we have a more just world. But you can see the effects of that. The rate of consumption on the planet is not sustaining ecosystems. Ecosystem services are in major disrepair. Things like clean air, clean water are all in major disrepair. Is it good for the economy? Well, for some people in the economy it's good for, but for others, the projections, and this is based on Nicholas Stern's information, he used to work for the World Bank, the global economy shrinks by 20% due to the impacts on natural systems, notably from climate change. You can see the cost of extreme weather events alone. That's happening right now with the increase in hurricane intensity that we're seeing, for example, in the southeastern United States. The developing nations get hit the hardest. They're already under economic pressure. But northern latitudes also get their share. As we know, the Arctic is warming at a disproportional rate. And then we've got the displacement of human populations, especially those living along coastal areas. That's going to have enormous socio-economic impacts. And this is one that I recently have gotten interested in. It's the connection between climate change and disease. And the two graphs you see there in the United States, on the top is the incidence of Lyme disease in the United States. Don't worry about the different colors. And then in 2015, the spread of Lyme disease in the U.S. being carried by ticks. And ticks have been surviving the winter, just like your beetles are up here, and they're moving north, and they're carrying Lyme disease with them. So climate change is not an environmental problem. It's a social injustice, it's a human health risk problem, and it's increasing. Okay, so now that was the doom and gloom. How do we kind of get to a point where we are valuing the planet's life-giving systems, the wild places that we need to get us and the rest of this biosphere through the bottleneck that we're headed for in the Anthropocene? I would argue that our remaining intact areas, and those could be terrestrial, aquatic, marine, they're all more resilient to climate change. The more stresses you put on ecosystems, the less adaptive and less resilient they are. And they also, the intact areas, because they have less stressors, are likely to be climate refugia or climate sanctuaries for climate-forced wildlife migrations. Intact coastal areas are better capable of absorbing coastal storm surge. Things like mangroves and wetlands that are in rapid decline are only going to magnify impacts to coastal cities and coastal villages that are going to see increasing storm surge as a result of sea level rise. Same thing for riparian areas. If you want to mitigate floods and drought, you want to have functional riparian areas in place. Diversity allows for adaptation, diversity at the genetic level, diversity at the population level, at the species level, all gives you more chances of adapting to a changing world. When you homogenize diversity at those scales, you reduce resilience. And it's also associated with our own human well-being. If you've read the book, The Last Children of the Wild, it talks about the connection between children's IQ levels and being outside. And because kids in this generation have gotten so addicted to mobile devices and computers, they're not outside as much, and it's having a depressing effect on IQ scores. Biodiversity is linked to human support systems. We've known that for a while as well. So, I mean, these are all anthropogenic arguments. Poverty is linked to environmental degradation, we know that. These are all anthropogenic. It's a mixture of anthropogenic and intrinsic value arguments. So I'm both a deep ecologist and a shallow ecologist for this talk, if you remember that distinction from the 1990s debate and what it meant to be an ecologist. So basically, in a nutshell, a wild planet is in everyone's best interest. You can make so many arguments for why we need wild things. And the best argument is to get out and see them yourself. Okay, now I'm going to shift gears and talk about where the wild places are, the remaining wild places that have high conservation value on this planet. Now, I did a paper with a bunch of international experts that came out in conservation letters in 2014. Brendan Mackey from Australia was the leader on that paper. And we wanted to know how much of the world's forests were still primary. Unlogged is primary. And why were those areas important? And you can see the definition of what a primary forest is there. And, you know, what kind of value do these forests have, and why should we target them in conservation reserve design? That was really the subject of that paper. How could we plug it in to international sustainable development and conservation area design goals? So primary forest, turns out from the paper we published and from a number of data sources that we used, 36% of the remaining forest cover has not had logging in it. And only 22% has had some level of protection. Up to 57% of the tropical species occur in primary forests. You can see some of those ecosystem benefits, particularly carbon. More carbon is stored in primary forest than a logged forest. Clean water, pollination, food web dynamics, soil productivity. You know, these are really the basics of ecosystem services that are in their highest ecological integrity state in primary forests. And there are other reasons. There are refugia for endemics, for species that are sensitive to human activities. There's cultural, aesthetic, spiritual values. Indigenous people have coexisted with them for millennia. Many of our medicines come from those places. Again, I'm mixing in intrinsic with anthropogenic in terms of values. And you guys are really lucky, because on a global scale, you've got the greatest amount of remaining primary forests using the definition of the FAO that was released in 2010. And you can kind of see each country's total primary forests. So it's really critical to the global network of primary forests that Canada saves its remaining primary forests. Now, in addition to primary forests, we also look at intactness. And there's a correlation. Primary forests can also be intact, but they may not be intact. You could have a primary forest that's a fragment. It hasn't been logged, but it's surrounded by a fragmented landscape. So now we're switching into intact areas that could be any kind of major vegetation type, not just forests. So I wanted to show this slide here on the top has a higher degree of intactness than the slide on the bottom. So that's just an example of what I mean by intact from a landscape standpoint. So this is an article that I co-authored that came out in Science magazine that was led by, again, another international team of remote sensing experts. And we kind of subtitled it Earth in 600,000 Pieces, because these are the last of the remaining intact pieces of the planet, all different vegetation types. Could be grasslands, forest, whatever. But this is it. This is what we have left on Earth during the Anthropocene. And, you know, the rest of the planet looks like this. It's crisscrossed by our footprint on a global scale. And the inverse of intact areas is what I call road rage. And when we build roads, we transform ecosystems, because we don't just build a road for the purpose of building a road. It comes with all kinds of other development. And you can see this very coarse scale road map that was done by Bill Lawrence in one of his papers that came out in 2014. So here's some statistics. At least 15.5 million miles of new roads will be built by the year 2050. That's a 60% increase in total road length. And those are going into the remaining wilderness areas and accelerating the rate of change. And this is the famous picture from Brazil showing what happens when you punch a road through and you get all of this development that's associated with that road that was the initial first cut through an intact forest. So one of the themes of Bill's work is stop the first cut. That first cut in a roadless area is the beginning of unraveling the system. Also, as we build more roads, we put more cars on the planet. Right now we're still running off of fossil fuels. That's not a good thing. And you can see the increase of cars going basically doubling in the next 15 or 20 years. A lot of cars on the planet. And with those come all of these road-related impacts that you see in the series of slides there associated with roads being built in different places. Roads also magnify fire effects. In the U.S., 84% of wildfires have an anthropogenic ignition. The more roads, the more fire ignitions. The darker those colors, the higher the percentage of fire ignitions related to human activity. So if you're concerned about fire, human access needs to be part of the solution. Some roads can fail like this, causing massive landslides, aquatic impacts. This stream comes from a heavily eroded system. This one comes from a less eroded system. You can see the effects on sedimentation rates and all the displaced wildlife mortality associated with that network of roads. So we set out to map those areas in this intact project, again, all biomes, and you can see all the different international partners that were involved in this Science magazine piece. We use this new OpenStreetMap database, which is on the web now. It uses a combination of remote sensing and some ground truthing. Citizen scientists are involved in this all over the globe, compiling information on road distributions. There's different ways to define roads, and we indicated that in the paper. We looked at all these different road systems, the extent of which we could pick them up using remote sensing. And we quantified the road influence zone, which is the zone from the road out, away from the road. The impacts don't just include the road, they extend out from the road prism. And we put a buffer around that. We altered the buffer from 1 to 5 kilometers to see what kind of effect that would have on mapping the remaining intact roadless areas. And that, again, is all in Science magazine. So here's a map of the world's global roadless areas, with the biggest patches being in the dark blue. And you can kind of see right off the top where they are highly concentrated, in the tropics, in Africa and South America, and you guys are really lucky. As you go north, you get into more of the Canadian boreal. Whoops, that went too fast. Let me drop back for a minute. So this is pretty much it. This is the 600,000 pieces in a digital map of the roadless areas of the planet. So the reverse of that are the roads, and scale matters in this. As you can see in the US, it looks like the whole darn country is a big spaghetti maze of roads. But when you zoom in on another scale, you start to pick up some blobs of roadless patches that are still relatively functional. But by and large, south of you guys, it gets really bad from a biodiversity standpoint in terms of the road network. Not all roadless areas are created equal. I don't have time to go into the methodology here, but what you see here is we used a ranking of roadless areas based on biodiversity attributes. There was a suite of biodiversity attributes like species richness and carbon, and we plugged those in and we ordered the roadless areas. The dark blue ones have the highest ecological score of roadless areas. And you can see, again, the tropics really come out as globally significant, but not just the tropics. Other areas also show up in blue, like you guys again. And then we did a plot of the percentage of roadless areas strictly protected for each of the continents versus their ecological index. So as you go across this scale of ecological importance, the importance goes up. And you can see that Australia is the only one that has done a decent job of protecting its high conservation value roadless areas. The rest of the world, those high conservation value roadless areas are underrepresented in the global network of protected areas. So we've got a lot of work to do to integrate roadless areas into sustainable development goals. That's pretty much the conclusion of that paper. All right, I'm getting down to the last few slides here, and I wanted to show you this pretty cool video. One of our partners has started this new movement to be road-free. He used to work for the European Parliament and got some measures through the European Parliament to rewild Europe. So there's hope in the places that we can still do rewilding that's happening in Europe right now. There's a big movement in Europe to rewild these landscapes. So this is a video that they put together. It's just to kind of educate folks on why roads are having a big impact on the planet. So we're going to click to that, and you guys will be able to see a pretty entertaining cartoon. So that was actually a direct outcome of the science work that went into the mapping that you saw in terms of how do you communicate this to the public. And let me flip back into the presentation because we're almost done, and I want to show you a couple of more things that I think are important. So I come from the country now that doesn't believe in science and thinks climate change is a hoax. And I've thought about this for quite a while when I wasn't depressed about what happened last year during the elections. And I actually think that there may be some silver lining in this. Because when I used to speak at conferences about the need for scientists to be more vocal, I used the four-letter word advocacy. That got people very nervous. And now I'm seeing this. Scientists coming out in demonstrations. This portion of the slide is the inauguration of Donald Trump on the Mall in Washington, D.C. This is the science demonstration a week later. Now, Donald Trump denies that this is a real photo. He says it was raining out. Okay? We'll give him the benefit of the doubt that the weather had some impact on his inauguration. But the important part of it is, look how many people showed up in defense of science. A week later, there was another demonstration on climate change. Same place, lots of people showed up. So people are taking notice of this. Scientists are becoming more active in translating their work into policy and management. Here are some of my heroes that have been doing this or have done it for a long time. I was inspired by Sagan. Even Einstein, if you read some of his famous quotes, all have some kind of policy or statement about society in them. Jim Hansen, who started the awareness on 350 as being this planet safety net in terms of CO2, is getting arrested at rallies now to stop coal-fired power plants. A lot of smart people talking about the effects of technology and too much dependence on technology. Stephen Hawking has been very vocal about this recently. Rachel Carson, where would we be if she had not spoken out? And Neil deGrasse Tyson, who has a message that I want you to hear. And when he says America, just keep in mind what this could be is North America, okay? So it's a U.S. perspective on what's been happening in terms of the retreat from science in the United States, but it could apply just about anywhere. So I'm going to click on that, watch this video from Neil, who has a lot to say about this. Whoops. Sound. That's weird. It was working when we tested it.
You got it muted on that bottom right.
Ah. Now we'll try it.
How did America rise up from a backwoods country to be one of the greatest nations the world has ever known? We pioneered industries. And all of this required the greatest innovations in science and technology in the world. And so science is a fundamental part of the country that we are. But in this, the 21st century, when it comes time to make decisions about science, it seems to me people have lost the ability to judge what is true and what is not, what is reliable, what is not reliable, what should you believe, what should you not believe. And when you have people who don't know much about science, standing in denial and rising to power, that is a recipe for the complete dismantling of our reformed democracy.
Left on us demand that educators around America teach evolution not as fact, but as theory.
Increasing number of parents showed skepticism about vaccinations. Voters have approved a ban on GMOs.
Call climate change unproven science.
That's not the country I remember growing up in. Not that we didn't have challenges. I'm old enough to remember the 60s and the 70s, and a hot war and a cold war, civil rights movement, and all this was going on. But I don't remember any time where people were standing in denial of what science was. One of the great things about science is that it is an entire exercise in finding what is true. Your hypothesis, you test it, I get a result. A rival of mine double checks it, because they think I might be wrong. They perform an even better experiment than I did, and they find out, hey, this experiment matches. Oh my gosh, we're onto something here. And out of this rises a new emergent truth. It does it better than anything else we have ever come up with as human beings. This is science. It's not something to toy with. It's not something to say, I choose not to believe E equals MC squared. You don't have that option. When you have an established scientific emergent truth, it is true whether or not you believe in it. And the sooner you understand that, the faster we can get on with the political conversations about how to solve the problems that face us. So once you understand that humans are warming the planet, you can then have a political conversation about that. You can say, well, should we further carbon credits? Do we do this? Do we put a tariff on it? Do we fund? Do we subsidize? Those have political answers. And every minute one is in denial, you are delaying the political solution that should have been established years ago. issues will come before you. And isn't it worth it to say, all right, let me at least become scientifically literate so that I can think about these issues and act intelligently upon them. Recognize what science is and allow it to be what it can and should be in the service of civilization. It's in our hands.
Okay, a couple more slides, and then I want to hear from all of you. So this is one of my favorite posters, and it was during one of the science rallies. And you all know we just went through a solar eclipse, and here's the consequence of ignoring science. So you can see in total defiance, looking up at a solar eclipse. Just doesn't believe anything. Okay, so I'm going to end with these last two slides because when I was talking to the students today, this kind of came to my mind in terms of how do you communicate your research, your findings, when you're talking to someone that doesn't have a science background, that has decision-making authority. And some of these concepts are from a book by Randy Olson called Don't Be Such a Scientist. And it's for scientists wanting to communicate. And this is how we're taught. We put forth hypotheses, we go out and design a study, collect data, do our results, conclusions are way at the bottom, right? So what he's saying that if we want people to understand us, we got to flip that upside down. Know your elevator speech. You got 3 floors to talk to a decision maker. By the time you get and hear that bell that goes ding and the doors open, you have to be able to communicate why your stuff is important to this person. Believe me, I know this. I had 15 seconds once to communicate to President Clinton why we need roadless areas. I had 3 minutes once with the Secretary of Interior to talk to him about a new national monument idea. I couldn't talk about my research findings first. I had to get right to this. Have everything else in your back pocket, ready to go in case you get questions. And know your limitations. Be true to the science always. And I'll leave you with this because this famous book, The 4 Agreements, that is an ancient wisdom written by the Mayans a long time ago in terms of how to present yourself in the world. You could present yourself the same way as scientists and still be advocates. So this is their language. I'm going to morph it a little bit. Be impeccable with your word. That's being true to the science. Always be true to the science. Speak with integrity. The scientific method is integrity. Don't take anything personally. A lot of people are not going to like what you have to say. But don't take it personally. You do it for a different purpose. If you're going to be out there advocating your work for a particular reason. Instead of don't make assumptions, state your assumptions. Be ready to talk about uncertainty because we never know what the full truth is. Always do your best, no matter how dire the situation may seem, no matter how big the ecological footprint is in the Anthropocene, there's always a solution. Whether you work at the local level, the regional level, or the global level, if you follow those 4 agreements, I think it would be a good guidepost if you choose to be communicating your findings to a different audience. And that's all I had to say. Do we have time?
Hello, thank you for your talk. I'm just wondering how the concept of rewilding isn't just a rebranding of wilderness. Because wilderness has a very specific white, privileged, male origins that's incompatible with a lot of indigenous worldviews. And if I think about that map you put up and you sort of suggested we should conserve the most wild places, those are all very indigenous places as well, like places with significant indigenous populations. So how is this not a return to enclosures and a denial of the right to development?
Well, any type of work going on in those intact areas is going to be in conjunction with indigenous rights. And I work with a number of international groups, one that's called INTACT, and INTACT works with those indigenous communities to respect their rights. So this is not a land grab or a tenure issue. It's working with the indigenous communities and maintaining the values that they are, that's sustaining their culture. So I don't see it as a land grab at all. I see it as working with them to ensure the future of their tenure and their rights, and also maintaining the biology of place. And I don't know if you listened to the story on the radio today about the killings that have taken place of indigenous people in Brazil that have happened in a big protected area that also had native people in it, including pre-contact people. The Brazilian government decided not to maintain the enforcement that was keeping folks from encroaching on that community. They removed the protections, and at least 8 indigenous people were killed. And the gold miners rushed in, and the loggers rushed in, and there's been encroachment that's going on right now. The indigenous people were violated by losing the enforcement that was occurring around their traditional holdings. So I kind of see it working the other way more than I see it being a land grab.
Thank you. Earlier you mentioned that you used OpenStreetMap for mapping roadless areas, and OpenStreetMap, I'm not 100% familiar with it, but a lot of it is citizen driven and things like that. So sampling efforts may not be equal in different areas. And I know Canada looked relatively roadless, but does that necessarily show, you know, all our logging roads and things like that that we have many of?
No, it won't. And it's not perfect. I mean, when you're working at a global scale, you're not going to have that zoom-in capacity. So that's why I showed that one image of the United States with all the red on it. At that scale of the country, it looked like there was nothing. But when you zoom in, you got, you know, some blobs that were in there at a finer scale. So you always have to ground truth. You always have to work with regional partners, local partners, in perfecting and improving the technique and making sure it gets better over time. But this is the first time anything like this has been done on a global scale, and it's really the message that was most important. Hey, you know, this is the last of the wild places on the planet. We can do a better job of mapping them, and we can also do a better job of protecting them.
Hi. Since the beginning of the talk, you were talking about the Anthropocene. I was just wondering what you think could be used as the indicator for the beginning of the Anthropocene. Because I've heard several things, like the possibility of even using chicken bones with the domestication of chickens around the world, that could be used as a marker in the sediments, or plastics.
Very interesting. I haven't heard the chicken bone one, but certainly heard about plastics. And it's in the, you know, there's a whole series of articles in this encyclopedia that looks at all the different metrics. Plastics is certainly one of them. And the advent of plastics and the impact on the environment at the scale that plastics have had is certainly one of the markers. And so it's really it's a hard thing to just use a single spike, and at least the geologists that were working on this didn't want to use a single spike. Instead, what they were more comfortable talking about was the acceleration. The Great Acceleration has also been used as a way to brand this era. And the Great Acceleration really started to take off post-World War II. That's when we see plastics show up at the scale that really was meaningful. That's when we see the age of the atomic age come into play. That's when population started to really jump. So if I had to be forced into, where are we going to put the golden spike, I would put a cluster of them right around post-World War II.
Given that we're just seeing some fairly recent research showing how widespread plastics are, that they're in the water, that they're in honey, they're in all kinds of things that we hadn't really contemplated before perhaps, and also the very recent information that CO2 levels are lowering the nutrient value of vegetation, how possible is it actually to protect places by keeping people out of them, really?
I don't necessarily think you need to keep people out of them. I think what you need to do is have compatible management. So, look at our parks. We don't keep people out of our parks. We don't keep people out of wilderness. It's just the level of human activity and the degree of human activity. There's certainly compatible human activity going on in protected areas. We've got examples of indigenous people living in large intact forests that have been there for many, many centuries. So it's not just the presence of people per se, it's what happens inside those areas. And even the park system in Canada and the United States, it may be functionally intact, but there's high concentration of human activity in some of the parks, or many of the parks. Like in the United States, they now bus people into the Grand Canyon, and they're busing people into Yosemite, because we love these places to the point where we can overrun them. So it's not just the absence of humans, it's the kind of activity and how we manage it so that we don't overwhelm the system that we all are receiving benefits from. Hopefully that made sense.
Just a quick question. Much of this is about roads, and in terms of terrestrial systems, certainly, roads must be one of the most insidious phenomena affecting ecological integrity. So are there any hopeful stories? Do you know of any cases where there have been concerted efforts to eliminate roads, to try and pull that back? And are there studies that follow in the wake of that? Because I'm not aware of any, and I think we could use them.
Yeah, there are a lot of examples. I mentioned rewilding that's happening in Europe. Where I'm from, the redwood parks in California, a big chunk of the redwood park was all clear-cut. And there's been a lot of restoration going on in the redwood park system. Not all of it is ancient grove. A lot of it is overplanted Doug fir, where they're trying to remove the Doug fir, replant with redwood, and they're obliterating their road prisms. The trick, though, is it's incredibly expensive. It's really hard to rip out a road. It's hard to put one in. It's expensive to put one in, but you've got to take out culverts, and if you do it right, you have to recontour the hydrology of the system, because roads will deflect hydrology. It will move sediments in a different way than a contoured landscape might. And there are examples happening in a lot of different places. It's just, the first rule of thumb is don't put the road in. So now if you're stuck with the road, figuring out how to pull it out in a way that's cost effective might be the way to do some restoration and put some people to work reconstructing the forest instead of deconstructing it. So there are examples going on in the US. I don't know what it's like in Canada, but I'm encouraged by what I've seen, because I've been in those places where they've recontoured and I couldn't tell there was a road there.
All right, if there are any more questions, Dominick will be here to receive them after this. And we'll be heading to the Thirsty Moose afterwards, so all of you are welcome to join us there. We'll get another hand for Dr. Dominick Dellasala, please.